Okay, so we're doing LP1 here. So this problem, we want to find two unit vectors in the xy plane that are perpendicular to the given line. So let's look at the line first. 3x minus 4y equals 17. All right, so this is some, let's see here. So when y is equal to 0, x is 5. Okay, so it's something like, I don't know, something like that. Okay. And now good news, I know a normal vector. Why? Well, because I know the this line L. I know the equation of the line is 3x minus 4y equals 17, and so I instantly know that a normal vector is 3, negative 4. Is that cool?
Yeah.
Okay.
Yeah, I got that.
All right. So now I want to find, the problem says two unit vectors perpendicular to this line. And good news, I claim that there are only two unit vectors perpendicular to this line, and these are they. Right? There's only two ways to go. And there's only, once you've decided which side of the line you're going on, there's only a single unit vector pointing on that side of the line perpendicular. So let's call this one U. I'll call that U1, and I'll call this U2. Well, good news. U1 points in the exact same direction as N. I know N. And furthermore, we have back in chapter 1. Oh, we're in chapter 1. So earlier in chapter 1, we have a formula for how to find a unit vector pointing in the same direction as a given vector. So U1 is going to be just N divided by the length of N. This is a really cool construction. Right? So good news, this is all easily computable. 3, negative 4. The length of 3, negative 4 is 5. So I get that divided by 5. So that's 3/5, comma, negative 4/5. So there's U1.
So you can't just multiply it by like a number to find a different vector?
Well, I did. I multiplied it by the number 1/5. Now, I can't multiply by just any old number of my choosing because critically the problem asks for a unit vector. Yeah. Does that make sense? You see, because we have to have the problem says find unit vectors.
Just another question about that.
Yeah.
Like, what I did, like I found two, so like I used the first vector, the first normal vector, so 3, comma, negative 4.
Yeah.
But like I used the multiple of like 6, comma, 8, and then I found a unit vector off that. Could you not do that?
Yeah, that's fine. It's sort of unnecessary. I mean, it's perfectly legal.
Okay.
Yeah, because it'll give you the same thing. If you take 6, comma, negative 8, and then its length is 10, you divide by 10, you're going to get 6 over 10, otherwise known as 3/5. And then negative 8 over 10, otherwise known as negative 4/5. It gives you the exact same answer. In fact, by the way, I mean, if you end up taking Math 107 with me, we're going to do an example where we do exactly that for particularly clever reasons. In particular, well, let me get to that in just a second. Okay, let me finish up the problem here. We got to find U2. And good news, look at this. U2 is the exact negative of U1. So it's just going to be negative 3/5, comma, 4/5. And yeah, so that's the other. No, this was just, I just took a negative. Yeah, I mean, so in other words, instead of, yeah, in the perpendicular thing, I had to kind of rotate 90 degrees, but here I'm rotating 180 degrees, which is the same as just, reflecting. Yeah. Okay, now let me your question about scaling something. So for example, let's suppose you wanted to find the unit vector in the direction of the following. So let's say 6e to the power of 17, 8e to the power of 17. So there's a vector. And suppose I want to find the unit vector pointing in that direction. Well, I could compute the length of this. And I could divide this vector by, by that length. And the problem is that when I compute that length, I've got a certain component of ugly that I'm sitting there carrying through the calculation, and it works out. It's not a problem. But it's more elegant to do the following, to say that so the u in this direction is the same as the unit vector in the direction of 6, 8. So I'm just going to divide by e to the 17 just because I know it doesn't change the direction. And then I can, or 3, 4, that's just as good. Right? I'm just dividing by numbers here, and as you've observed, it doesn't make any difference for the unit vector pointing in that direction. So then this I divide by its length, and that gives me 3/5, 4/5. So that's pretty much the question you were asking about. Is it okay to scale it first? And yeah, absolutely. In the context that we were working before, scaling this first doesn't really bias anything, but in this case, it kind of does. And so computing the length of this is algebraically much more convenient than computing the length of that. Yeah. And we'll see that in Math 107, this is going to be particularly useful in one little instance. Okay, let me stop this.